viewers, welcome again to another exciting episode of Mathematics and I. It's a favorite presenter, just like you know, and today I will be lecturing on how we can solve problems on interquartile range, how we can solve for interquartile range of ungrouped data. Now, sometimes data can be grouped and data can also be ungrouped. Now, the question we have today are ungrouped data, and we are told to solve for the interquartile range. Now, without wasting time, how do you go about this? Now, interquartile range has a formula, and the formula is third quartile minus first quartile. That is the formula for solving interquartile range. Third quartile minus first quartile. Now, how do you solve this problem? Third quartile alone has its own formula, and first quartile also has its own formula. Now, the formula for third quartile, which is Q3, are when the number of observations is even. Now, when I say even, it means numbers that can be divided by 2 without any remainder. So, when the numbers of observation, which we have now, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is even, the formula for third quartile is 3 into the bracket of n over 4 raised to the power of th. Now, th here shows position, the position of the third quartile. Now, in Q1 also has its own formula, and the formula is just n over 4 raised to the power of th. Mind you, this formula is applied when the data are even, the total number of data are even. Okay, now, how do we go about this? The best way I can explain this to you that you understand is actually using the table. Okay, we actually prepare a table which is called a cumulative frequency table, and the table says we have x, we have f, and then we have cf. Now, cf actually means cumulative frequency, f means the frequency, and x means the data that we are given. Now, if you see the data here given originally, we have 45, 47, 52. Now, I have another 52, but there's no need to write 52 because we have a frequency column over here. So we go to 53, and 55, 56, 58, 62, and 80. Now, these were the set of data that were given. Now, let us bring out their frequencies. Now, the frequency of 45 is 1. Because we have just 145 in the set of data as given. Now 47 also 1, 52 we have 2 of it, and the others I think are just 1, 1, 1, 1, and 1. Alright, now the next is how can I get my cumulative frequency column? Now to get your cumulative frequency column, it simply means adding your frequency step by step. Now, the first frequency I have is 1. Now there is no number to add to 1, so here remains 1. Okay, but now 1 plus 1 gives us 2, okay, and 2 plus 2 gives us 4, 4 plus 1 gives us 5, 5 plus 1 gives us 6, 6 plus 1 gives us 7, 7 plus 1 gives us 8, 8 plus 1 gives us 9, and 9 plus 1 gives us 10. Now this is our cumulative frequency column. Okay. Now, once you do this, the next thing we are going to do is now calculate for our Q3 and our Q1. Now, like we said, the formula for calculating Q3 is Q3 is equal to 3 into the bracket of n over 4 all raised to the power of th. Now, what is n in this question? N is our total number of observation. And our total number of observation is 10. So here becomes 3 into the bracket of 10 over 4 all raised to the power of th. Okay, now 3 times 10 gives us 30 over 4 all raised to the power of th. And 30 divided by 4 will give us 7.5 position. Now 7.5 is not the answer, but 7.5 is the position of our third quartile. Now, the question is, how can I get the exact data that is in the 7.5th position? Now, this is why I prepared a table, and you get this using our cumulative frequency column. Now, if you check our cumulative frequency column, there is actually no 7.5, but we have 7.5 inside 8. Okay, now we can't choose 7 because 7.5 is bigger than 7. So if we say 7.5 is in 8, it means our answer to that question is 58. So our Q3 is 58. Alright, let's go to Q1. Now the formula for Q1 says just n over 4 all raised to the power of t-ish. Are we there? Now n is 10, so here becomes 10 over 4 raised to the power of t-ish. And 10 divided by 4 will give us 2.5, which is 2.5th position. Again, 2.5 is not the answer, but it's the position of the answer. So how do we get that? Again, our cumulative frequency column comes in. Now, 2.5 is inside 4. Okay, so what is the number for x in cumulative 4? We have 52. So our Q1 is equal to 52. So without wasting time, now that we know our Q3 and we know our Q1, we can now solve for our interquartile range. Now remember the formula for interquartile range says Q3 minus Q1. So our Q3 when we solved was 58 and our Q1 when we solved was 52. So it means our answer to that question is 6. So this is how you can solve actually for interquartile range using this method. So I believe you have learned something new today again, and don't forget to subscribe to our channel if this is the first time. You are welcome to the family. We are always happy to have you here, and I believe as you go through our series of videos, you will begin to get a perfect understanding about mathematics. Please don't forget to share our videos. Don't forget to tell your friends, to tell your friends to tell their friends, and that is how we can actually conquer mathematics in the whole world. So till we meet again in our next video, don't forget, my name is Jeff Nino, and thank you for watching.